In the last video, we tried to find the area of the region, I guess this combined area between the blue and this orange, the area, I guess, of the overlap between these two circles. And we came up with 9 pi minus 18, all of that over 8. What I want to do in this video, show you could have also used a typical graphing calculator to come up with the same result. And it would have actually evaluated the definite integral. So let's see how you do that. And this, what I'm doing here, you could do this for a traditional, if we're dealing with Cartesian coordinates, rectangular coordinates, or for polar coordinates, because it's really just about evaluating a definite integral. So we wanted to evaluate 9 times the definite integral from 0 to pi over 4 of sine squared theta d theta. So how do I do that? Well, I can go to second calculus, and I do the fn int, that's definite integral. So let's use that function. And the first thing you want to say, well, what are you taking the definite integral of? And we're taking the definite integral of sine, actually I want the parentheses, sine, and I could use any variable here as long as I'm consistent with what I am integrating with respect to. So I tend to use just the x button because there is an x button, but we'll just assume that in this case x is theta. So sine of x squared, instead of sine of theta squared, where once again we're assuming x is equal to theta. And then the next one, you specify, well, what's the variable you're taking the integral with respect to? In this case, it's x. If we put in a theta here, then we would want to put a theta there as well. And then you want the bounds of integration. And you should assume that your calculator, or if you're doing this, if you're in radian mode, or if you're dealing with radians, you should assume you're in radian mode. I just did before I evaluated this. We're going between 0 and pi over 4. 0 and pi over 4, and then we get this number, and then we wanted to multiply it times 9. So my previous answer times 9, if I just press times, it just does the previous answer times 9 is equal to this number, 1.28429. So let's verify that that's the same exact value we got when we actually evaluated the integral by hand. So if we take 9 pi minus 18 divided by 8, what do we get? We get the exact same value. So anyway, hopefully that's satisfying that we got the same value either way, and a little exposure for how you might be able to evaluate some integrals using a calculator, which can be useful when you can't actually evaluate them analytically.